Hello friends. The biggest concern companies have in using LLMs is the data privacy and protection. So the companies, they want to leverage LLMs to solve business problems, but they are concerned about sending the private data, especially the PII, personally identifiable information, over the internet to models like GPT hosted by OpenAI or other models like Palm hosted by Google, right? So in this video, we will see a mitigation technique to solve this problem. Okay. So let's imagine uh, you work for a law enforcement organization and you receive uh, the complaints from the from people, right? So here is one example. Let's say my name is John Dio, and on a particular date I lost my wallet, and then it has some credit card, etc., etc., right? So let's say this is the customer complaint. Now you receive lots of these documents, and let's say you are investigating one of the case and you want to find out some specific details about a case, right? So you want to use LLMs to quickly find out what was the stolen wallet, right? So if this model is hosted on premise, we would not have any issue sending the context as it is. But since this model is hosted by a third party like OpenAI or Google, etc., we don't want to send this context as it is, right? So one technique to mitigate this is to anonymize the data. So what do we do is we anonymize PII from this given context and we replace with some dummy data before sending the context to the LLM. And once LLM returns the output, then we do the de-anonymization so that we get the correct answer using the correct data. Okay, so that's what we are going to do. All right, so for this we are going to use a library called Presidio. It's developed by Microsoft. Okay, so install a bunch of libraries in addition to LangChain. So we are going to use LangChain framework, and we are going to use some of the features from the experimental release as well. We will be using OpenAI for the LLMs, and then Presidio for the anonymization, and Faker to generate some fake data, right? So Presidio, it simply identify the PII and it replace with name, I mean something like this. So it replace with name, person, the location, credit card, etc., right? But we want to replace it with some dummy data so that the LLM can understand it better. Rather than sending the data like this, we want to replace this with an actual person name, I mean some fake person name, so that LLM can process it better, right? So for generating such fake data, we are going to use Faker. And then this FAISS library, so it's for creating the vector store and then storing the embeddings, and for a similarity search. So I guess you are already familiar with RAG system, right? All right. So here we have a document. So it said the date, who is the witness, and the subject. They have lost some wallet, and it, hey officer, my name is so and so forth. On so and so date, I have lost my wallet, and it has this credit card number. It has my bank account number. It has some ID cards, this DL number. It also has some social security number, etc., etc., right? It has the date, time. It also has this Polish identity card, so and so forth, right? And then the email ID, etc., etc. Now this is the document. So we are going to do the regular stuff we do in RAG. So we take this document, we split it into two chunks, we create embeddings, we store them in the vector database, and then we ask the questions, right? But before storing the data into the database, we want to anonymize, right? So that the PII uh, is taken care of. All right. Okay. So typically we would have multiple PDFs or multiple documents, but in this case we have a single document. So here we are reading our document content to this documents variable, which is LangChain variable. Okay. And then here we are, we have a very simple helper function, this print colored PII. All it does is when we provide some text to it, the text within this angled brackets, it print in a different color so that we can see where we have the PII. Okay. So all we are doing is we are identifying these angled brackets and we are printing that stuff in a different color. Okay. All right. So from LangChain, here we are taking this Presidio reversible anonymizer. Now, as I mentioned before, the reason we are using reversible anonymizer is because once we get the output from LLML, we want to de-anonymize so that we get the right person name and right PII details, right? So this is reversible anonymizer. All right. So all we need to do is simply call instantiate the anonymizer. So Presidio reversible anonymizer. I'll tell you about this faker. We are setting it to false because we are not yet replacing the values with some dummy data. First, we are simply identifying the PII. And then we simply call anonymizer anonymize and we provide the document. We are printing this using this helper function print colored PII. Okay. All right. So for this given document, we simply got the document back with PII masked, right? So the date, person, it identified the location and the credit card code, some bank code, the driver license, the SSN. So the Presidio, it already have some knowledge of what is PII, but it may not be able to detect some other information which we consider PII, right? So what the predefined PII, it has detected and it has masked. Okay. Now here we can look at the mapping as well. So we simply do the de-anonymizer mapping. So what it does is it show the PII type. For example, here we have the credit card and then the actual data value. Now we might have multiple times, right? For example, if you look at here, the PII type, it's the email address, but here we have two email addresses. So the first one, it says email address. For the second one, it says email address _2, right? It does the same thing for person or any other variable which appeared multiple times. Okay. So this is looking good. We are able to identify the PII. But as I mentioned, we might have some custom PII, right? For example, if you look at this one, here we have what is called this Polish identity card, right? So it's this ABC 1 2 3 4 5 6. It did not identify as PII, right? Now, if you look at the original document, for example, here we have the timestamp and here we have the date, right? But it has identified both of them as date time, right? So that one and this one here, date time 2. Now we might want to differentiate between a date and time, right? For example, we might want to anonymize only the date, may not be the time, or maybe the other way, right? So we want to be able to define custom PII patterns. So here what we are doing is from Presidio Analyzer, we are importing the pattern and pattern recognizer. So first we define some patterns. So first we are defining this Polish ID pattern. So as we have seen here, it has these 3 alphabets. It has these 3 alphabets followed by 6 numerics. So let's say that's how the Polish ID looks like. So here we are simply saying, hey, I'll have 3 alphabets followed by 6 digits. Okay, so that's my Polish ID pattern. And then here we have a time pattern, which is this hours, minutes, and AM and PM, right? So that's this pattern. Now, once we created the pattern, we will add these patterns to the recognizer. Okay, so here we are creating this pattern recognizer, one for Polish ID and one for time. and then adding these recognizers to the anonymizer. Okay, now we will do the same thing again. So here we are resetting the mapping, and we rerun the anonymization again. So this time if you see, so this one correctly identified as date time, and then here this one identified as a time, right? Earlier it identified as date time. Now this one is identified as a polish ID. Okay, polish or polish, however you call it. Okay, so that's it. That's good. So we have defined our own PII rules, and we are able to identify or mask them. Okay, that's good. And then again, if you look at here, we should have a new field, polish ID. Okay, and we should also have time, which is also new. So we have date time here. So here we have a time, which is this 9:30 a.m. All right. And then now we want to add, instead of sending the data like this to an LLM, we would like to replace it with some fake data so that LLM can understand the data or the text better, right? So the readability will be better. So what we do is, we are doing exactly the same thing, a Presidio anonymizer, but this time we are setting this faker operation to be true. Okay, and this seed for the repeatability. So if we use the same seed, we get when we run the next time, we get the same fake data. Okay, all right. And then we are adding the two recognizers, right? The polish recognizer and the time recognizer. Now we are doing the same thing, but this time, as you can see here, this date is different from the original date. So for example, let's look at two fields. So here we have the date as October 19th, and the witness name is John Dio. Now, after replacing with fake data, so here we have a different date, and now the name is this Brian Cox. Okay, so similarly, all other fields gets replaced, because here we are using this faker library, and it already knows the credit card, what is date time, how should email address looks like, etc. So all the predefined values it is able to replace with some fake data. But as you can see here, we have two attributes or two variables, this polish ID and also time. Sorry, these are not variables, the values. The faker could not understand, so it hasn't replaced. Okay, so similar to how we inform the Presidio about these two custom patterns, we will inform about these two custom patterns to the faker as well. Okay, so here we are instantiating the faker, and then we are creating this function fake polish ID. Okay, so this is how it should look like. It has first three alphabets and then some six numbers, right? So if we call this function, it will generate a fake a polish ID with the pattern we defined. So as you can see here, it has these three alphabets and then some six numerics. And similarly, the time, right? So we are using this time function, and it should be this hours, minutes, and AM or PM. So when we call this function, we got some fake time. Okay, so what do we do is, to the Presidio anonymizer, we add these two patterns as what is known as these operators. So here we are defining two new operators. One is this polish ID with this function we defined here, and the second one is time, the function here. Okay, so we added these two operators to our anonymizer. Okay, now let's call the anonymizer on our document. So here we are calling it, and this time, in addition to the predefined fields like date, names, location, etc., our polish ID is replaced with some fake ID, and also the time is replaced with some fake time. Okay, so this is all looking good. And if you want the mapping or the de-anonymization, we can do that as well. Okay, all right. So far we have looked into the Presidio and faker to achieve the anonymization, right? we haven't done any LLM or RAG related work, right? Now we are going to do the RAGs using LLMs. All right. Okay, this part we have already seen. Now, this you must have already seen because I already created a number of videos on RAG. If you are new to RAG, maybe refer to those videos. So with the recursive character splitter, we are simply going to split the document into smaller chunks, right? Because this document might be a book. Now, LLMs have a context and they cannot they can have only a couple of thousands of tokens as context, right? So we are going to divide this book into smaller chunks, maybe one page or one paragraph each chunk, right? For that, we are going to use recursive character splitter. And we need to create embeddings. We are using OpenAI embeddings and this FICE for a similarity search and for the vector store. Okay. So first here we have anonymized our document, right? In this case, we have only one document. So with this one, we have already defined our custom patterns and for both the Presidio as well as for the faker, and we have anonymized the document. And then we are splitting the document into smaller chunks, and each chunk will have 1,000 characters, and there will be 100 character overlap between the consecutive chunks so that we can preserve the context between the chunks. Okay. And then here we divide it into smaller chunks. And then we are using OpenAI embeddings model. And here we are creating a vector store and storing the vectors, creating the embeddings, so on and so forth, right? So here we have all the chunks and we are creating the embeddings, right? And then we have the retriever. So whenever we give a question, the FICE, it create embeddings for that question, and it find out similar vectors within the vector store and return the most similar top vectors. Okay. And now we are going to implement the RAG here. So up to this point, we have taken our documents, we have anonymized, we have split them into chunks, we have created the embeddings, and we have stored them in the vector database. Okay. Now, so here we have a template. So answer the question based only on the following context. So this one is important, right? Based only on the following context, right? We don't want to LLM to make up some answers, right? And then here we have the question. So we define the prompt from the prompt template. So this chart prompt template, and we are defining this LLM model using OpenAI. And then we are going to create this chain with a bunch of steps, right? This code looks a little odd, but all we are doing is, as you can see from here, here we are taking the input. From the input, we are getting this question, and then we have the prompt. We are applying the LLM model, and the returned output, we are processing it, right? I'm not sure why LangChain use this language, this runnable pass-through, runnable lambda. It sounds a bit weird, but the concept is very simple. It's a chain. We are creating this anonymizer chain with a bunch of steps. Okay, and then finally we simply invoke the chain. So here we are asking, where did the theft of the wallet occurred, what time, and who was it stolen from, so on and so forth, right? Now, when we do this invocation, so this question gets converted into embeddings, and the similarity set, so on and so forth happens, right? But as you know, our vector database contain the anonymized data, okay? Because what we stored in the vector database here is based on this anonymized data, right? So to the LLM, when we process the data or when we generate the output, it is purely based on the anonymized data, not the actual data. Okay. So that's why we got this answer with anonymized attributes, right? So this is not our actual person name, and this is not the correct time, and this location is also not correct because we haven't de-anonymized the output. Okay, so in these 4 or 5 steps, we don't have the de-anonymization. So here what we are going to do is we simply take this anonymizer chain, which we have defined here, and we add one more step, which is simply de-anonymize. Okay, so this output, it gets de-anonymized before returned to us. Okay, so here we are asking the same question, but this time, as you can see, the output is John Dio, who is the actual person from our original document. So here we have John Dio, that's the right person. And then sorry, where are we? Yeah, so this is the right time and this is the right location. Okay, so that's how we mitigate sending the PII to LLMs, and we are able to de-anonymize so that we get the right data. Okay, all right, so a couple of other questions. So what is the content of the wallet? And so the LLM, it has processed, and it said the wallet has these 4 items: a credit card and a driver license, social security number, and Polish identity card. And all these, if you remember this, ABC 1 2 3 4 5 6, that's the right number. Okay, and whose phone number is it? So this phone number belongs to John Dio. Okay, all right, very quick recap. So we don't want to send PII to LLMs. So here we are anonymizing the data before sending to LLM, and once we receive the output, we de-anonymize it so that we get the right attributes. So the way we are doing it is simply using the Presidio. Okay, from Microsoft. All we need to do is simply supply our data. It will identify the PII and it will mask the data. Now, if we have some custom PII, then we can define those patterns and we add those patterns to the anonymizer so that it will identify those patterns as well. For example, this Polish ID. And then we don't want to send data like this to LLMs. We want to replace it with some fake data so that the LLMs can understand better. So for that, we are using this faker library. Similar to what we did to anonymizer, we are creating these patterns and adding them to the faker so that it can create the fake data in that pattern, right? So here we have created or anonymized the data by replacing the PII with some fake data. Now comes the LLM part. All we are doing is we are simply taking the documents, we anonymized and we split them into chunks. We created embeddings which store them in the vector database, right? And then here we are creating this chain consisting of multiple steps. So it consists of the input, the prompt, the LLM model, and parsing the output. Okay. We haven't added the de-anonymizer yet. So the output is still based on the fake data, right? But here to the anonymizer chain, we have added one more step, which is to de-anonymize. Okay. Then when we ask the question to the LLM, even though we are sending the fake data, the response we get contain the actual attributes. Okay. So that's how we are able to mitigate the issue of sending PII to LLMs. So that's all for this video. Thank you very much.